Hello, ladies and gentlemen. Today we're going to be taking a look at volume. So volume of prisms and cylinders. That is, what's the space on the inside? So take a look at these beautiful pictures. Notice the cubes that are filling up a three-dimensional shape. That's what we're talking about when we talk about volume. So volume, the basic idea is the number of cubic units it takes to fill up the interior of a solid. So rather than being in units squared, we're going to be talking about units cubed. So when you take a look at a weird shape or a weird picture or any sort of shape for that matter, we want to know the volume. We're talking about the space inside. How many little cubic units would be sitting in here filling up this space on the inside? How many would I be able to draw? How many would I be using to fill up this space? So to attack this problem, we're going to be focusing on the inside of our shapes and not so much about that surface area on the outside. So this relies a little bit more on volume formulas, and you may already be familiar with some volume formulas, but we're going to maybe make them a little bit more formal now. So the formula for volume of a prism. Please open up your little foldable to the prism page again. And on one side you have written things about surface area. On the other side of the staple you need to write things about volume. So volume of a prism. This is what we need to write. Volume equals big capital letter B and then H. And let's do a little clarifying what those things stand for. V, obviously you know. B is more than just a number on the base. B stands for the area of the base, or what would be the base according to his name. H stands for the height of the prism. Okay, or the height of that shape if it would be sitting on that base. How tall would it be? So that's the formula we're going to be using. It's a little bit more than the whole idea of length times width times height that you may be familiar with, because our prisms are not always going to be this rectangular prism type that we're used to. This right here is a hexagonal prism. Notice how the hexagons, there are two of them, top and bottom. That's what gives him his name of a hexagonal prism. The sides are all rectangles. That should always happen on any prism. But the two distinct sides are supposed to be the bases. The two sides that are not rectangles or are different from the others, supposed to be the bases of that shape. That's a key idea. So let's look at finding the volume of this right prism, and we're going to round our answer if we need to here. Draw this one in your notes near where you wrote that formula for volume, okay? This is not your standard rectangular box. Okay. This is a trapezoidal prism. Why is it called a trapezoidal prism? Because there are two sides on this prism that are trapezoids, the front and the back. All the rest are rectangles. A rectangle is the side of a prism. Okay, the bases are those two other shapes that are, different perhaps. Perhaps they're also rectangles, but most of the time in our work we've been looking at pentagons and hexagons for being those bases, triangles. So this happens to have a base of a trapezoid. Now you might say to yourself, hey, but it's not sitting on the base. Isn't the base what it's sitting on? Not always. We know many times three-dimensional solids, boxes, can get knocked over. It's not like it turns into a different sort of shape. It's just knocked over. That's what's happened to this. The base is not what it's sitting on. It's what he's named after. Okay, so trapezoidal prism is what we have. That means if I'm going to do that volume formula, volume equals the area of the base times the height. The area of the base happens to be a trapezoid, remember. So we have to do the trapezoid as the base. To find the area of a trapezoid, that's where you go to your yellow sheet. 1/2 height, base 1 plus base 2. So if I look at my trapezoid and I just want to find that area of that base, I have to use this trapezoid formula. 1/2. What's the height of the trapezoid? 7, according to the picture. What's the base of the trapezoid? 9. What's the other base of the trapezoid? 6 at the top up there. And this is what I use to calculate the area of that trapezoid face there. I need the area because I need to multiply it by how tall it is to find that volume. So I'll type in my calculator 0.5 times 7 times 9 plus 6 would be 15. And I get an area for that base of 52.5. So far I have volume equals 52.5, that's the area of the base, times the height. So now I need to get the height of my prism. How tall would this box be? Now be careful, 7 looks like it's the height, but remember this box is supposed to be sitting on its base. Somebody's come along and knocked it over. The base is supposed to be the trapezoid. So if the base is the trapezoid and I were to sit him upright, that means this 4 right here would be his actual height. So we're going to take that area of the base times 4, because that's the height, and the total volume of this trapezoidal prism is 210 inches cubed now, because we're talking about volume measurement. How many cubic inches can fit inside this shape? Okay, so be thinking about this whole different way of looking at volume. We need the area of the base, and the area of the base is not always what it's sitting on. We have to know how to name these prisms. Okay, so now let's take another look at how we would use the volume to solve for a missing side. If you want to add this one on that page, you certainly can, but we're going to use the volume to find basically an x measurement here in our picture. So let's go ahead and understand again that volume equals area of the base times the height. So if I have the volume of 360 cubic feet, if I plug in 360, and now I need to find the area of the base. What would be the base on this box? Well, it's a triangular prism, because it has two sides that are triangles. All the rest are rectangles. Those two sides are supposed to be the base, and they are. That's good. It's sitting on the base. So I need to find the area of the triangle, because that's the B. That's the big B that I need to find. So I need to find the area of the triangle. If I bring up that 8 up here to my top triangle here, just because it's easier to see, do I know that area of that triangle? If I was going to do the area of this right triangle, here's what he would look like. If I pull that triangle right off the picture, he'd have 17 this way, he'd have 8 here, we don't know here, we don't know, but we could find out, right? We're going to need to find out, because in order to find the area of that triangle, we need to know the base and the height. And I have the height of the triangle is 8, but I don't have the base. That's a big question mark. So I'm going to put an X there for right now, or maybe a Y, because I already have an X in my picture. I need to find that. So how am I going to do that? Pythagorean theorem. Y squared plus 8 squared equals 17 squared. So y squared, I don't know. 8 squared is 64. 17 squared is another large number, 289. And then I'll subtract the 64. So I'd have y squared equals 225. And then when you square root 225, it says the y would be 15. So that means this measurement down here is 15. 15. So if I was going to find the area of the triangular base, I'd have to do the base of that triangle times the height of that triangle divided by 2. So 15 times 8 divided by 2 is 60. So the area of the base is 60. Okay, so far I know the area of the base is 60. And I'm going to plug that back into my volume here, my volume formula. I needed that area of that base. Now the h is the height. How tall is that thing going to be? Well, that's the x, right? That's the x we're looking at. So the x is there, and now we just have to solve for x. I have 60x equals 360. To get the x alone, I would divide by 60, so x would equal 6. That tells me the height has to be 6 feet. So using that volume formula, then, we can find missing measurements on shapes if we have a given volume we want to have, or a given ending volume. So let's look at what if we have a cylinder now. What if it's circular rather than made up of all these rectangles? So again, volume of a cylinder, same idea. We have a circle on the base though, so that's where the pi r squared comes from, and then we have the h. So if you want to write the formula in your notes, it's volume equals pi r squared h. That's how you find the volume of a cylinder. Let's put one example in your notes for that, and we should be good to go. Here's a picture of a cylinder. So the volume formula for a cylinder, volume equals pi r squared h. Make sure you draw the picture and show the work next to it. It'll help you out later on a test or a quiz. Volume equals pi. What about the r? Well, 22 feet is all the way across. A radius is only half, so we'd have 11 squared. What about the h? 16 for the h. So I'm going to plug in all these numbers here and see what I get when I type it in my calculator. Pi 11 squared times 16. And you can type that in your calculator all at once. Volume equals 6,082.1 feet cubed. Okay, cubic feet for that final volume. So, ladies and gentlemen, using these formulas to calculate volume, remember we're finding that space inside of these shapes. How many cubic units fit inside these shapes? Thank you very much for taking good notes.